I believe we're live. I joined a little bit early today. If you can hear me, you're here already. Thank you for being early. If you can hear me, put a plus in the chat so I know you're here, or not, or so that I know that you can hear me, and also that you're here. Let's see if this works. Okay, great. Do that and that. Awesome. Hi, Raymond. Welcome to the stream. All right, I see a couple of us have already joined today's stream. Awesome. If you can hear me, put a plus in the chat for me so I know I'm not just speaking to myself in my own world. Let me know. Hi, Caleb. Welcome. I still don't know if you can hear me or not. I know my mic is on, but I don't want to keep moving forward unless... Oh, thank you, Favor. Thank you for the plus. All right, great. You are in the right place if you're here for pre-algebra, free lesson on estimation. I know a couple of you were here before. If you're returning, let me know in the chat. If you're returning, put an R. If you're new, put an N. Super excited for everyone here today. This is a new free lesson. Our previous free lessons were on multiplying and dividing fractions. You can check those recordings out on my YouTube page. But today we have an entirely free lesson on estimation, which is rarely talked about, but super, super powerful skill that you can boost your number sense skills and just build a solid foundation in all types of arithmetic. That's what we'll be talking about today. Welcome, Favor. Welcome to the stream. I see that you're new. We love that. Welcome, welcome. All right. Before I begin, you can check out the link on the bottom of the YouTube or in the YouTube description to the workbook. So there's a link to the workbook. You can access that so you can follow along in today's lesson without having to copy down any of the questions. These are professionally designed workbooks so that you can just focus on the learning and not wasting time copying down what's on the screen or on the board as you would see in class. So go ahead and access that link to the workbook. And before I introduce myself, if you know any friends or family members that would benefit from today's stream, pre-algebra is for grades 5th grade, 6th grade, 7th grade, 8th grade. If you know any friends or family members that you think would benefit from today's stream, go ahead and copy that link, that YouTube link, or wherever you're joining from tonight. Copy that link, share it with them, and we can all join the fun. All right. A little bit about me. I'm Eddie. I've been teaching high school and college math for about 9 years. I've also private tutored every grade level from 6th grade math all the way to students preparing for graduate school, like MBA programs, all that. I found a love for math very early on. I got A's in all my math courses in school. I got a perfect score on the SAT and got into my dream school, UCLA. After graduating from UCLA, I started teaching right away and found and discovered my passion for teaching math. And it showed because my students have gotten into the top universities in the nation. They've gotten perfect scores on their SAT math section. They've gotten 5s on their AP exams and just performed above the national average in almost any metric you can measure in math. But most importantly, they had fun along the way, and that's what we're here for today. I'm here to show you that math can not only be fun, but also accessible and affordable. So without further ado, let's get started. I love starting off my lessons with a little bit of something called a vibe check, because I know right now it's 5 p.m. in the West Coast, but on the East Coast, it's 8 p.m. So it is a little later in the day. And I know for those of you, this is might be closer to your bedtime. So I want to get our brains reactivated here, get our gears running again. Why do you think we estimate? In the chat, why do you think we estimate? Why is estimation necessary? Why is it powerful? Like, why would we ever estimate anything when we have calculators in this day and age, AI? We have so much stuff. Why do we estimate? And let me change my scene here. Boom, there we go. Awesome. In the chat, why do we estimate? Okay, I see one. To get to the answer faster. Yes, to get to an answer faster. Okay, that's a good one. Why else would we estimate? Like, let's say we're estimating how much something costs. We could estimate to find a more accurate answer. Okay, that's great, Caleb. I completely agree, right? Sometimes we estimate so that we can get in a certain range, right? Somewhat of a ballpark of what the actual answer might be. But the reason we estimate is to save time, right? Exact calculations can take a long time. And by the end of today's lesson, by the end of today's lesson, estimation, you're going to be able to estimate so quickly to get us just the fast idea of what the answer could be. So let's start with our first example here. In 2022, roughly 1,526 flights landed and took off from LAX per day. It's a lot of flights. Estimate the total number of aircraft operations at LAX in 2022. All right. So roughly 1,526 flights per day. We want to estimate the total number of aircraft operations in all of 2022. In 1 year, there's approximately 365 days. And we know that in 1 day, roughly 1,526 flights land and take off from LAX. So 1,526. Now, who in the world would want to do this in their head without taking out their calculator, right? Without taking out their phones, right? Without taking out Mathway, all this stuff, right? Instead, let's try to estimate. What would you estimate 365 to? And what would you estimate 1,526 to do this multiplication much faster to save time and get us to some idea of an answer? What would you change or estimate 365 to and 1526 to? Let me help you out with this first one. 1526 can be estimated to roughly 1,500. And 365, this is where some experience in estimation would help. We don't want to estimate this to 350 because we know 350 times 1,500, that might be a little difficult to do. So instead, we're going to round up to 400. And if we multiply these out, that's very simple, right? 15 times 4 is 60. We have to tack on 4 more zeros, 1, 2, 3, 4, and we have about 600,000 aircraft operations at LAX in 2022. Now let's see what that actual number was in 2022. The actual number was 556,913. And I would argue that 600,000 is a very, very good estimate to 556,913. By the end of today's lesson, you're going to be a master at estimating any type of operation, and you're going to be surprised at how powerful you feel without having to use a calculator. And I would argue the brain is much more powerful than a calculator. Let's dive in. So rounding is very important to estimating. Let's say you're at your local supermarket with $25 of cash. Your basket has items priced as such. 1, 2, 3, 4 items priced as such. Do you need to calculate the exact total, or will an estimate be good enough to check if you have enough money? So let's check. $3.99, what would you estimate that to? What would you estimate $2.79 to? What would you estimate $4.49 to? And what would you estimate $8.50 to? There are a couple ways of doing this, but these first two are fairly straightforward, right? $3.99 we can estimate to $4. $2.79 we can estimate to $3. $4.49, some would argue to estimate that to $5, and $8.50 to $9. So if we add all these up, we get 7 plus 5 is 12 plus 9 is 21. So $21 is the estimate to the sum of all the prices of these items. Now you have $25. Is $21 enough? Well, you have to account for sales tax, right? 10% on top of 21 would be about an additional $2.10. That's $23. Doesn't really come close to 25. So that's how we can check that we do have enough money. Now, for those of you that are more advanced in rounding, we can round 449 to 450, and we can recognize 50 cents plus 50 cents is $1. And then 4 plus 8 is 12, giving us 13 total. When we add these up, add these, and we get a total of $20 as an estimate. All right. Now, this is where you come in the chat. An engineer is calculating the weight a bridge can safely hold. Cars and buses have different weights, and the bridge needs to support many vehicles at once. Should the engineer estimate or calculate exactly? Let me know your responses in the chat. Should the engineer estimate or calculate exactly? If you were the engineer and you were building this bridge and you were responsible for anything that happens on this bridge, would you estimate or would you calculate exactly? Let me know in the chat. I see a few of us have joined on Instagram as well. Welcome. And keep in mind, cars and buses have different weights. There may be trucks. There may be like tow trucks, right? That might carry some extra weight. All right. I see a few of us are saying calculate. Does anyone think estimate? Should the engineer estimate here or calculate exactly here? I know Favor is here, Caleb is here, Raymond. What would you all do? Okay, I see the general consensus is to calculate exactly. But let's think about how we could possibly calculate exactly here. If we don't know how many cars or buses or trucks are on this bridge, there's no way we can safely calculate exactly what the total weight on the bridge will be. So in this case, an engineer would estimate and we would always round up. So let's say there was like a big school field trip, right? And we had a bunch of buses on that bridge. Well, then we would calculate as many buses that can fit on that bridge. And I would calculate, like, we have to be able to hold as many buses as possible on this bridge. And that way we can safely assume that any number of cars or buses can safely pass through the bridge with the bridge safely holding. I would calculate the census of vehicles that drives over the bridge. We could also do that. Great, what's the word? Suggestion, Wanda. Great suggestion. Yes. So now, with this next part, we're going to practice how to estimate just like we did in our vibe check. To estimate and approximate answers to a calculation, we round our figures to one significant figure. One significant figure is we may have multiple zeros with just one whole number that is not zero. It isn't an exact answer, but as we have seen, the solutions are close, and like our LAX question, could sometimes be scary close. So approximate each of the following. For 49 times 82, I don't want to take out my calculator. I don't want to take out my phone. I want to do this in my head. Mentally, I want to be able to estimate. What would we estimate 49 to, and what would we estimate 82 to be able to estimate this type of multiplication? Welcome back, Chloe. 49 to one significant figure. What would you estimate that to? And for 82, what would you estimate 82 into one significant figure to make this estimation much quicker, faster, and will still be in the same ballpark as the actual answer? Great. 49 we can estimate as 50, and 82 we can estimate as 80. So now 8 times 5, pretty simple. That's 40. Tack on the zeros. Great, Caleb. And we have 4,000. Let me tell you what 49 times 82 actually is. The actual answer is 4,018. So this is a pretty good estimate, right? This is a very good estimate. Without using our calculators, just by estimating, we got to 4,000, and we're very happy with that. Now, for letter B, same idea. Great, Sandy, Wanda, Chloe, awesome work in the chat. We have 398 can be estimated to 400, 612 to 600, and 203 to 200. Estimating these individually and then adding them up, we get 1,200. Oops. 1,200. 6 plus 2 is 8, plus 4 is 12. We still got that 100. The actual answer to this is 1213. So give or take, I'll take this estimate any day. Knowing how we just solved these two problems by estimating, try C and let me know what you get in the chat. 2,981 divided by 49. We haven't worked with division just yet, but using the estimation skills we just learned and talked about in letters A and B, let me know what you get in the chat to letter C. You don't have to tell me exactly each step that you're doing. You just have to try estimating this and see what works, see what happens. What do you get? It's crazy that we're already doing this. And with each slide, we're going to start ramping up the level. I always like to start off pretty simple so that everyone is able to access it and also be able to access the slides later on as well, so that everyone can stay with me throughout the entire lesson. Great, Caleb. Great, Chloe. I love that we're participating. Another part of my lessons is that I encourage you to participate and make mistakes. When you make a mistake and you fix that mistake, that's when true retention and true learning occurs. So do not be afraid to make a mistake. I encourage you to make mistakes, right? I really do. So 2981, we can estimate to 3,000. 49 can be estimated to 50. We know that 3,000 divided by 50, if we were to do this out, we know if we use the division by chunking method, we know 50 goes into 3,000 at least 10 times. So that's 500. If we subtract this, that's 2,500. And now we know 50 goes into 2,550 times. And if we add the 10 and 50, we know that is 60. You could have done this a different way, right? You could have done this method where we simplify, cancel. The 10s cancel. 300 divided by 5 will be 60 again. You could have done it that way. Many different ways to do this, but I chose to do it division by chunking. Okay, great. Let's bump this up a level. Approximate each of the following. Now, 9.9% used to be sales tax, so that's why I chose that 9.9. Let's approximate these, and let me help you out with this. 9.9% can be estimated to about 10. So we have 10% of multiplied by 5,987. That's pretty close to 6,000. So 10% of 6,000. How do we do that? 10% is 10 in 100, right? Percent means per 100 times 6,000. The hundreds cancel, leaving just 60 times 10, and that's 600. The actual answer to this problem, 9.9% of 5,987, I did this before I hopped on today just because I was curious, is 592.7, roughly. And 600, I would say, is a great estimate of this without having to deal with many more numbers here, right? Letter B, let's try this one out. Great, Chloe. Yes, 6,000 over 10. Yes. We have 31.2 plus 68.8. Man, I really don't like working with these types of numbers. Let's estimate. 31.2, what can I estimate that to? 68.8, what can I estimate that to make this a lot easier? What can I do here? 31.2, 68.8. Yes, Chloe, you were so close. I mean, you basically were there, right? You just needed one more step and you would have been good. It's awesome. 31.2. This time, I probably wouldn't round up, right? We have been rounding up a lot lately, but 31.2 is pretty far from 40. So instead, I would take 31.2 and round down to 30. Great, Caleb. Great, Chloe. Awesome. So I could say 30 plus 70 in the square root all over on the bottom, 4.13 divided by 2.12. Well, I could change that. I could estimate that 4.13 to 4 and estimate the 2.12 to a 2. And now I have the square root of 100. Yes, exactly. Root 100, Chloe. And great, Caleb. 2.12 to a 2. And now, without using a calculator, I would argue that if you knew how to estimate like this, you probably got to this answer way faster than if you were to input all of these operations in the calculator. I would also argue that you probably would make a mistake while plugging these into a calculator. And for those of you that haven't used the square root function on your phone yet, you would spend some time searching for that. The order of operations might get messed up here because we have two divisions, right? Lots of arguments I can make about how powerful estimation is compared to plugging it into a calculator just to get a few couple more decimal numbers. The actual answer to this is 5.13. And now I also want to mention this is just a skill that we can use. We're not always going to estimate, right? Certain problems will ask us to be exact most of the time. But generally speaking, just in society, I think estimation learned in math class is so applicable just in everyday life. And that's why I like teaching it, although some schools omit it from their curriculum. So 9.9 squared, 9.9, yes, we did root first, Chloe, because the root is only over the 100 and not the denominators or the terms in the denominator. 9.9 squared. Well, 9.9 is roughly 10. So 10 squared is 100. And I would also note here something I made a mistake is I want to put a squiggly after the initial one and then put equal signs after, right? Because we're estimating, we want to approximate that first step. So again, here as well, instead of an arrow, I will put a squiggly. Squiggly is 100. 9.9 squared is exactly 98.01. And I'd say 100 is a very good estimate of 98.01. Great stuff in the chat. Love to see it. All right, let's bump it up a level again. Now let's estimate these roots. Very different from what we've been doing, but I did give you a little bit of a precursor with roots just now in letter B. We're going to estimate these roots to one decimal place. And you're going to be surprised at how quickly you'll be able to do these in a little bit. Let's take, for example, radical 3. And I'm going to change the color here. Radical 3. Well, let's think about radical 3. 3 is not a perfect square. Let's think about the other perfect squares that are around the vicinity of 3. Radical 3 is in between radical 1 and radical 4. So I know radical 1 is 1 and radical 4 is 2. So I know radical 3 will be 1 point something, right? 1 point something. Now let's think about how far is 3 from 1 and how far is 3 from 4. Well, from 3 to 4, we're adding 1. And from 1 to 3, we're adding 2. So the difference between these is 2, and the difference between these is 1. Total, 1 and 4 are 3 apart. So if you took about 2/3 of the way, 2/3 of the way from 1 to 4 is 3. 2/3 is approximately 0.67. We want it to one decimal place. 0.67 rounds to 0.7. And this is how we would estimate in our heads, right? This is estimating. The actual answer to radical 3, and it's an estimation because we have, this is an irrational number, would be 1.732, which if we were to round to one decimal place would be 1.7. All right, let's check out the next one, radical 75. So radical 75 is in between also two perfect squares. We know radical 81 is equivalent to 9. And so the next number in line would be 8. 8 squared is 64. Now let's test how far 64 is from 75 and how far 75 is from 81. Given what we just did in part A, I want you to try this and let me know what you get in the chat to one decimal place. What would we have here? 8 point what? What number would you put right here? 8 point something. We know that these numbers are 11 apart and these numbers are 6 apart. So total of 17, maybe you can round to 18. We know that 75 is closer to 81 than is to 64. So we know this number in the box has to be greater than 5. That's for sure. And then we can use a little bit more of this information that 64 and 75 are 11 apart, 75 and 81 are 6 apart to get more a more accurate estimation for radical 75. And then I'll show you something really cool here as well. Ooh, I see Chloe said 8.6. That's awesome. Yeah, I would, yeah, 8.6 or 8.7. Exactly, right? We're estimating here, right? The fact that we're estimating to even one decimal place is wild, right? You could have just said 8.5 and I would have taken that as an estimation because you know that it's between 8 and 9, right? You know that it's between 8 and 9. The actual answer to this is 8.66 and then repeating, right? 8.6 repeating. Or actually, I think there's other stuff, but it's 8.66 roughly. And so 8.6 or 8.7 both work. I would have written 8.7 just because 11 and 6 add up to 17. 11 is pretty close to 12. 12 is twice that of 6. So it's really similar to the intervals that we have here. So I would guess, all right, 2/3 is 0.67. Let's round that up to 0.7. But Chloe, I really like how you thought there, 8.6 or 8.7. Really good estimates if you're thinking about both ways. Another way to do this would be radical 75 is equivalent to radical 25 times 3. Well, radical 25 is 5, keeping that radical 3. We just estimated radical 3 as 1.7. So we can say squiggly 5 times 1.7, and that is equivalent to 8.5. And that's why I said 8.5 would have been a decent estimate as well. So hopefully we're finding the fun in estimation here, right? We're working on our mental math skills, right? We're working on number sense. We're working on building a solid foundation and understanding what the operations mean as well. Okay. All right, let's bump it up a level again. Approximate each of the following. Now we're dividing by numbers less than 1, right? We just started doing this. Or actually, did we do this yet? We haven't done this yet. This is completely new. We're dividing by numbers less than 1 now. Let's take a look. Oh, you can't see? Oh, I see from here. I wonder if there is a way for me to... Oh, I could do this. I could do this, and then you can see what I wrote here. Right, 5 times 1.7 is equal to 8.5. I got this 1.7 by taking the approximation or estimation of radical 3 we did earlier. Thank you for letting me know, Chloe. Appreciate that. All righty. Let's take a look at the next one. Let me change this back. Okay. Approximate each of the following. Letter A says 20.45 over 0.49. Well, 0.45 we can approximate to 0.5. So in this case, for A, I can say 20.5 over 0.5. 0.49 rounds up to 0.5. So now I'm thinking about how many times does 0.5 go into 20.5? A simpler way to do this would be to get rid of this decimal place by multiplying both top and bottom by a 10. That will move that decimal point to the right one place value. So we'll have 205 divided by 5, and using division or simple cancellation, we can find that this is 41. So an approximation for this fraction would be 41. Ooh, Chloe, I see you put 21. That's also a good idea as well. Let's actually try that, right? If we have 21 divided by 0.5, if we're dividing by a half, that's essentially saying multiply by a 2, right? We can also multiply both top and bottom by 10 here to get 210 over 5, and that'll be 42. And notice that 41 and 42 are in the same ballpark, right? We've gotten to an estimation, and both seem okay to me, right? Both work. Let's try letter B. Letter B says 52 times 6.78 all over 0.5. Well, 52 I can estimate to 50. 6.78, I don't really want to multiply by 6.8. I don't want to multiply by 6.5. So I'm going to round this up all the way to the nearest whole number of 7. And on the bottom, I'm dividing by 0.51, which is approximately 0.5. So this will equal 350 divided by a half. And reminder that when we're dividing by a half, we're actually multiplying by a 2, right? Whatever we're dividing by, we can always multiply by its reciprocal. People know this as KCF, keep, change, flip as well, is also how students learn it in school. Great, Caleb. Great, Chloe. So this is going to equal 700. And that would be an estimation, an approximation of this fraction. Lots of stuff happening here, right? But this way is way faster than having to plug all this in a calculator, I would argue, once we get really good at this. And you can work on this in your practice problems, check out my video solutions, and get even better at this after today's lesson. Awesome work. Love that we're following along. Let's keep it going. 4.8 squared. Well, 4.8 is awfully close to 5, right? We don't want to deal with squaring 4.8. We don't want to do that. So we have 5 squared times. Now, this is where it gets a little iffy. We have 11.3 squared. Do we want to round all the way down to 10? Or do we want to just round to 11? Now, that's everyone will be different on that. For me, I'm just trying to approximate. So I'm going to actually multiply by 10 squared because that's easy to do in my head. On the bottom, 3.28 minus 3.12 yields us 0.16. That's simple math that we can do in our heads. But instead of 0.16, I'm going to round that up to 0.2. Now, 5 squared is 25. 10 squared is 100. So we have 2,500 over 0.2. And if I multiplied both top and bottom by 10, that would give us 25,000 divided by 2, which is, let me rewrite that on the bottom here, would be 12,500. And that would be our estimate. And I would say, I wouldn't forget to say for this approximation, since I rounded down a lot from 11.3 to 10, I would say our approximation here is definitely less than the actual answer to this fraction. Chloe, you said 11. Let's try 11. We have 5 squared times 11 squared all over 0.2. Now, 5 squared is 25 again, times 11 squared. 11 squared is 121 all over 0.2. Now we can estimate here again, right? 121, I can estimate to 120. So I really like that we're trying this problem out as well. Thank you for suggesting that, Chloe. We have 25 times 120. Oh, I should be putting squigglies here since we're estimating once again. Don't forget to do that. And now 25 times 12. If we have 12 quarters, that's $3. So we have 300. Tack on that 0. So that's 3,000. That will give us, let's see, equals. I want to make sure everyone can see what I'm doing without covering the work. So I'll go 3,000 divided by 0.2. I'm going to multiply both top and bottom by a 10. And that will give me 30,000 divided by 2, which is 15,000. And now it's going to be really hard to approximate stuff like this when we are dividing by numbers less than 1. So this is to show that when we have nice numbers less than 1 that we're dividing by, like 0.49 or 0.51, where we can use 0.5s. Very nice, right? We're dividing by a half, which means we're basically multiplying by 2. It's easier, but with 0.2s, right? With a 0.16 estimated to a 0.2, it becomes a little trickier, right? It becomes a little trickier, but I would say for the answer that this will give us, 12,500 and 15,000 would be decent estimates to the actual answer to this fraction. Welcome, Barbara. 0.2 is timing by 5. Yes, that's correct, Chloe. Let's check that out. If we are, let me do that in green here. If we divide something by 0.2, that's the same thing as saying dividing by 2 over 10, right? Since 0.2 is 2 over 10, that's the same thing as saying divide by 2 over 10, which is the same thing as multiplying by 10 over 2. And that's how we get times 5 is the same as 0.2. Another way you could have written this is 0.2 is the same as 1 over 5 instead of writing 2 over 10. And you could say, dividing by 1/5 is the same as multiplying by 5. And this is where multiplying, dividing by fractions, our previous free lesson, comes into play, right? That lesson comes first, and then we go into estimation so that everything is aligned, right? Everything is aligned. So that's how I have designed the curriculum for my course as well. With problems like these, is it better to estimate up or down? Great question, Caleb. As long as you're getting to the closest possible value, I would say it's preference. But for example, like 4.8, clearly you want to round up to 5. You don't want to round down to 4, right? Hopefully that helps answer your question a little bit. On C, may I ask how you got 10 squared? Yes. Instead of doing 11 squared, I opted to find something much easier to work with. So I rounded all the way down to 10 instead of 11. And Chloe suggested 11, so that's why we tried 11 as well. And it turns out we get to a pretty big difference in the answers, but for what the actual fraction will give us, not too bad. Nikki, I see you on Instagram. What age? So pre-algebra is for, I would suggest pre-algebra for any student in 5th, 6th, 7th, or 8th grade. and I'll get into what other courses I teach as well after today's lesson. We're almost there. All right, let's practice this now. Let's say your friend Penny has worked out this on her calculator, and her answer is this mess, 13,332.29917. Penny's answer is not sensible. Sensible meaning, yeah, I mean, the meaning of it doesn't make sense, right? It doesn't make sense. How would you describe sensible? We should ask Eleanor does English or something. By rounding each number to one significant figure, work out a sensible estimate to show that her answer is not sensible. So let's get to work here. Let's prove to Penny that her answer does not make sense. It's just bogus, right? Not even close. So let's check. How would we do this? 81.2. Well, what would you estimate 81.2 to? Or might as well estimate this entire thing and let me know what you have in the chat, right? 81.2. I don't know if I would want to estimate to 81 or 80. I know for 59.2, I'm definitely going to estimate this to 60. I'm definitely estimating 1.9 to 2. But for 81.2, this is I think the phrase is gut shot. It's whatever you prefer. For me, I would choose 80. Yeah, Chloe, same. I would choose 80 here just because it's easier to work with than 81. And all we're trying to do is trying to get in the same ballpark, right? I just want to prove to Penny that her answer does not make sense at all, not even in the same ballpark, right? So 80 times 60, that's simple. We have 10 times 10, which is 100. 6 times 8 is 48. So we have 4,800. 4,800 all over 2 squared. 2 squared is 4. And this is equal to 1,200. Wow, take a look at that. 1,200 is so different than Penny's answer from her calculator. So my guess would be what Penny did here is she probably forgot to put parentheses around something and possibly squared the entire thing instead of just the 1.9. That's probably what happened with Penny using her calculator, right? And this is kind of right. This whole lesson from the start, I've been saying your brains are more powerful than a calculator. You don't want to rely on a calculator when estimation gets you to an answer much faster when you're looking for quick answers. And this is a prime example here. When you use a calculator, oftentimes you will make a mistake by not putting parentheses in the correct places. Because right here, do you see any parentheses in this statement? We don't, right? This expression doesn't have any parentheses. But when we plug this into a calculator, you'll have to plug it in like this. 81.2 times 59.2 divided by, and you need to make sure you have 1.9 squared in parentheses. What Penny probably forgot are these parentheses. So what the calculator did is they multiplied 81.2 times 59.2 divided by 1.9, then squared the entire thing. Unlucky, but we could have just estimated, right? That's why we're learning this, right? Estimating 1,200, we know that Penny's answer is not sensible. Let's try one more problem here as an application problem. I love baseball. Go Dodgers. I love baseball. And I just made up some numbers. Baseball game tickets are really expensive nowadays, especially in LA. I'm probably not, some other teams out there, but in LA, the baseball tickets are very, very expensive. So I did some research and came up with this problem. So let's check it out. For a baseball game, let's say 19,763 tickets were sold for $93 each. So this is an average. And let's say 26,235 tickets were sold for $207 each. Yes, Caleb, go Dodgers. Work out an estimate for the total amount of money paid for these tickets. Okay. So now for those of you that want to know the answer to this problem, take out your calculators, try this out, see what you get, and let me show you how quickly you could get this using just estimation. 19,763. That's roughly 20,000. They were sold for 93 each. Well, that's about 100. Oops, I put a 0. Oops. All right, let's just write that again. 20,000 times 100. And that's equal to 2 million. Right? 100 times 10,000 would be 2 million. Wow, we already made $2 million, or the stadium did, or Dodgers did. We have 26,235. That's about 25,000. Yes, great, Chloe. I see you're keeping up here. Times $207 each. So I'm going to say that's about 200. Now, 2 times 25 is 50. And I have 3 zeros, 2 zeros, so 5 zeros total. I'm going to tack on those 5 zeros. 1, 2, 3, 4, 5. And we see $5 million. Add these up, we have 7 mil. So the total amount of tickets sold, or total amount of money paid for all of these tickets for roughly 45,000 seats, is roughly $7 million. And guess what the actual answer is? I don't know. Let's use a calculator to check. If we use the calculator and we said, let's do 19,763 times 93 plus 26,235 times 207. 7,268,604. Way less fun doing it on the calculator. Number one, right? That's my number one thing about this. Way less fun. And our estimation is already so close to what the actual number is, right? All we needed was an estimation. And that's why estimation is so powerful. That's why I cover it in my curriculum for pre-algebra. Now, if you enjoyed this lesson and you're still here with me, put a plus in the chat so that I know you're here. I am super excited to share what I have planned for this course, pre-algebra. Call your parents over. This would be a good time if they're not already here. Welcome to the stream. I'm excited to share what I have planned for pre-algebra. Let's take a look. And let me change my scene really quick so everyone can view the slides here. Okay, great. Let's get started. Our lesson may be ending, but your progress doesn't have to. My EdSpace Pre-Algebra Full Year course starts on October 6th. That's less than a month from now, less than 3 weeks from now. Really, really coming up. Each course includes 2 engaging live and interactive lessons each week, just like the one you saw today. Pre-Algebra will meet Mondays and Wednesdays, 5 to 6 p.m. Pacific time. That's 8 to 9 p.m. Eastern time and 6 to 8 p.m. Central time. So twice a week, running from October 6th all the way to June 5th. Caleb, feel free to ask. Every lesson is video recorded. So every lesson is recorded. If you miss a lesson because of some event, family emergency, anything that might happen throughout the course of the year, you can always go back and watch the recording. Every lesson comes with professionally designed workbooks so that you can focus on the learning and not copying down every problem or image or anything like that on your notes. After every lesson, you will get practice exam style questions that come with detailed video solutions. And this will help you master the concepts and skills that we learn in the lesson before we move on to the next lesson. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge per hour? And let me tell you a little story about how I got into private tutoring. I used to tutor pro bono, so for the public good. That's what pro bono stands for in high school as volunteer work. Then in college, I used to tutor for about $35 to $40 an hour. But in college, I didn't know much, right? I didn't know what my students were going to be seeing in class. All it was homework help, or maybe they took an exam and I helped them fix their exam, like retakes and things like that. Yeah, like so many things I didn't know. And that's why I only charge $35 to $40 an hour. But 6, 7, 8, 9 years now in teaching experience. Yes, Barbara and Chloe, spot on. I used to charge a minimum of $100 per hour. And for students that were preparing for their MBA programs or preparing for big tests like the GRE, things like that, I used to charge $200 per hour to those students. And that's what families have to choose between, right? What works and what they can afford. It's always, if you can afford them, usually you're just getting homework help or just a bunch of practice problems that don't mean anything. Or if the tutor works, they're probably not affordable. They're probably super expensive. Affordability versus effectiveness. You can never get both. And that's why we created My Headspace. You get all of this 2 times a week, all month. So 7 to 8 lessons per month for just $99 a month. That's 8 times cheaper than what I would have been charging per hour as a private tutor. And why stop there? You'll get a 20% additional discount on our annual package if you pay upfront. That's 60 live lessons, practice problems, video recordings, video solutions from October 6th all the way through June 4th. 20% off on the annual package. That comes out to less than, I think, $15 per lesson, which is absolutely insane. But that's why we created My Headspace, to make education accessible and affordable, and to make expert education, right? Effective education, affordable and accessible nationwide and eventually globally. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee, because I am confident once you start with me, you're going to be filling those gaps in your learning, reinforcing those concepts and skills that you're learning in school, and eventually even get ahead so that you can achieve at the top of your class. It is a first come, first serve, so this is a limited time offer. If you're interested, text me code word START to my number, 512-900-1283. If you're not with your parents right now, or anyone that would be willing to, or you're going to be convincing for you to join my course, you can scan that QR code, save it for later. You can take a screenshot, whatever you need to do to join my course. Join me at My Headspace. Start your math journey with me at My Headspace and achieve more than you could have ever dreamed. If you found me through socials, you already know that I'm pushing out content every day on TikTok lately. You can follow me on all socials at Eddie Does Math, EDDIE Does Math. I think I can do something here where I can put the, oh yeah, there we go. Eddie Does Math. You can find me on all socials. You can interact with me there, right? I love people that comment, and I comment back. I love interacting with my viewers. Love the engagement. So feel free to engage in that. Caleb, I know you had a question. Ooh, so that's the thing. I can answer questions that pertain to the lesson, but I won't be able to answer questions apart from the lesson. So let's say we talked about estimation today and you wanted to talk about, say, fractions. For sure, we'll talk about fractions. But unfortunately, inequalities and literal equations don't really match with estimation. So it wouldn't be right for me to cover that during my lesson. Good question, Caleb. All right. Well, thank you everyone for joining tonight. I'm looking forward to speaking with you through text or through the phone, discuss some pain points that you may be feeling in school, that I may be able to help solve through my course. Thank you for your time tonight. Love the engagement. Caleb, Chloe, Barbara, Raymond. There were a couple others. I think Wanda. Yeah, I mean, everyone today was so participatory. Love it. And I will see you next time. Bye, everybody.